In this video, we are going to look at the derivatives of polynomials and exponentials. The directions say to differentiate the function. So let's start with number 1. Suppose g of x is equal to 4x plus 7. Now, we're going to differentiate term by term. Now, the derivative of x with respect to x is equal to 1. So when I look at g prime of x, I'm going to look at the derivative of 4x with respect to x. If the derivative of x with respect to x is 1, the derivative of 4 times x with respect to x is equal to 4 times 1. And then the derivative of any constant is 0. Well, 7 is a constant. And so the derivative of 7 with respect to x is equal to 0. And so, therefore, g prime of x, when I simplify, I just get 4. That's example 1. Let's take a look at example 2. Suppose f of x is equal to x to the 75 minus x plus 3. Now, the derivative of x to the 75 with respect to x by the power rule is 75x to the 74. The derivative of x with respect to x is equal to 1. So you notice how I put all of this on the side. Now, I want f prime of x. So we're going to, again, go term by term. The derivative of x to the 75 with respect to x, we get 75x to the 74. The derivative of x with respect to x is 1. The derivative of any constant with respect to x is 0. 3 is a constant. So the derivative of 3 with respect to x is 0. And so, therefore, f prime of x is 75x to the 74 minus 1. That's example 2. Example 3. Suppose f of t is negative 2e to the t. So the derivative of e to the t with respect to t is e to the t. So if I want the derivative of negative 2e to the t, the negative 2 goes along for the ride, and then the derivative of e to the t with respect to t is just e to the t. And you're done. That's the derivative. So that's example 3. For example 4, we have w of v is 1.8 v to the negative 3. So the derivative of v to the negative 3 with respect to v is negative 3v to the negative 4. Because remember, negative 3 minus 1 is negative 4. So if I want w prime of v, I'm going to write down this 1.8, and then I'm going to differentiate v to the negative 3 with respect to v. Well, that's negative 3v to the negative 4. But negative 3 times 1.8 is negative 5.4. So this is negative 5.4 v to the negative 4. Therefore, w prime of v is negative 5.4 divided by v to the 4th if we get rid of our negative exponents. And that's example 4. if we take a look at example 5, so on example 5, we have the following. F of x is equal to x to the 3 halves plus x to the negative 3. So f prime of x is differentiating term by term. I get 3 halves x raised to the 1 half plus, and then the derivative of x to the negative 3 with respect to x is negative 3x to the negative 4. Okay? Now, this is 3x to the 1 half divided by 2 minus 3 over x to the 4th. Now, the LCD between 2 and x to the 4th is 2x to the 4th. Okay? And so on the first term, I'm going to multiply top and bottom by x to the 4th. So in other words, I'm going to take 3x to the 1 half, that's in the numerator. I'm going to multiply by x to the 4th. And then notice how 2 is in the denominator, and I'm going to multiply the 2 by x to the 4th. That way I get a common denominator, right? And then I'm going to take 3, which is in the numerator. I'm going to multiply by 2. And in the denominator, we have x to the 4th. And I'm going to multiply that denominator by 2. Okay. Now, remember, 4 plus a half is 4 and a half, right? Which is equal to 9 halves. So, therefore, f prime of x is equal to, now, I get 3x to the 9 halves minus 6 in the numerator. In the denominator, I get 2x to the 4th. That's how we do example 5. Example 6. Suppose I had f of t is equal to t to the 3rd plus e to the 3rd. Okay? Now, remember, the derivative of t to the 3rd with respect to t is equal to 3t squared. Okay? So again, we're going term by term. So if I want f prime of t, I get 3t squared. Now, we have to be careful because e to the 3rd is a constant. And the derivative of any constant with respect to t is 0. So we get a 0 here. And so, therefore, f prime of t is equal to 3t squared. So that's how we do example 6. If we take a look at example 7, suppose we had s of t is equal to 1 over t plus 1 over t squared, which is t to the negative 1 plus t to the negative 2. S prime of t is negative 1t to the negative 2, right? Power rule, minus 2t to the negative 3, which is negative 1 over t squared minus 2 over t cubed. Now, the LCD between t squared and t cubed is t cubed. And so along the first term, I'm going to multiply the numerator and denominator by t. Okay. So I'm going to put a t here and a t up here. Okay. And so when I go to simplify, I get s prime of t is negative t minus 2 divided by t cubed. That's number 7. Let's take a look at number 8. Suppose y is 2x plus the square root of x. But isn't this 2x plus x to the 1/2? Now I want y prime. Remember that the derivative of x with respect to x is equal to 1. Okay? The derivative of x to the 1/2 with respect to x is 1/2 x to the negative 1/2. And so here, the derivative of 2 times x with respect to x is 2 times 1. And then I've already established that the derivative of x to the 1/2 with respect to x is 1/2 x to the negative 1/2. And this is 2 over 1 plus 1 over 2x to the 1/2. Now, the LCD is 2x to the 1/2. So I'm going to take 2 times 2x to the 1/2 and divide by 1 times 2x to the 1/2. Okay? And then I'm going to add 1 over 2x to the 1/2. So it's a good exercise in getting a common denominator. And so therefore, y prime is 4x to the 1/2 plus 1 divided by 2x to the 1/2. And that's how we do example 8. Let's take a look at example 9. Suppose I had the following. Suppose f of x is equal to x cubed times x plus 3. I have no idea what to do with the product of two functions just yet. But what I do know is the distributive property. And so what I can legally do is take x cubed times x, which is x to the 4th, and then I'm going to add x cubed times 3, which is 3x cubed. And then if I want the derivative, so in other words, if I want f prime of x, the derivative of x to the 4th with respect to x is 4x cubed, right? So we can write that here off to the side if we need to. There's nothing that says we can't write this to remind ourselves. The derivative of x to the 4th with respect to x is 4x cubed. The derivative of x cubed with respect to x is 3x squared. So I'm going to add 3 times 3x squared, just like this. So this is 4x cubed plus 9x squared. Now, a good exercise is the following. We can take f prime of x and write it as follows. So I'm going to factor out an x squared, and then what I have left in parentheses is 4x plus 9. So we're working backwards. And that's how you do number 9. Let's take a look at one last example here. So on example 10, we have the following. Suppose k of r is equal to e to the r plus r to the e. Okay. Now, this one's tricky, and you have to be careful here. Now, remember, the derivative of e to the r with respect to r is e to the r. But e is constant, okay? So when we look at this second term, we're going to apply the power rule. So remember that the derivative of r to the e with respect to r is er to the e minus 1. I know it looks weird, but remember, e is a constant. And so when I want k prime of r, I'm going to get e to the r plus er raised to the e minus 1. And that'll do it for this video. And we looked at 10 examples that involve differentiating polynomial and exponential functions. Okay, thank you.